We're going to be looking at modeling with parabolas. So what that means is just looking at word problems. Before we get started, I want to review what we did yesterday, which was write the equation of a parabola that has a vertex and passes through a point. So remember, it's not enough anymore unless we know the a value to just tell us write the equation given a vertex, because we don't know how steep or if it's facing upwards or downwards. So we now have to have a point again unless we have that a value. So I'm going to go ahead and write out what we know. So we know that this is y equals a. We know that the equation in vertex form is x minus h squared plus k. So we can plug in our h and our k. So this will turn into y equals a. Because it's x minus -1, it'll turn into x plus 1 squared, and then we have minus 4. So that is a piece of important information, and so is this point. So what we're going to do is take the point -3, -12, and plug it in for x and y. So we'll take the y value, -12, equals a, and then we'll take the x value, -3, and plug that in for x. And then we get -12 equals a. -3 plus 1 is -2. -2 squared is 4. So a lot of students want to combine these two things, but we can't because they are not like terms. So remember, 4a and -4 you have to leave separate. So we get -12 equals 4a minus 4. You can add 4 to both sides. So we get -8 equals 4a. Divide by 4. So a equals -2. So we write our final equation, which would be y equals -2 times x plus 1 squared minus 4. All right, so we're actually going to be doing the same exact thing, but we're just going to be given a situation, so a word problem. So for this first one, we are going to create an equation of a parabola from the scenario. So our scenario that we have is Jessica kicks a soccer ball that reaches a height of 10 feet and travels a distance of 60 feet. So what will probably help us is to draw this out. So that's going to be my first step, is to kind of draw what information we have. So I know the height of 10 feet is important and a distance of 60 feet. And we're obviously not drawing this to scale, and that's completely okay. So the ball's going to come from the ground, obviously, and we know it's going to go something like this. That's why we're creating an equation of a parabola, because it looks like a parabola. So I'm going to label the height, which is 10 feet, and then also the distance, which is 60 feet. Okay, there's a couple other points that we can label. So this right here is the origin, so I'm going to label that 0, 0. This point is 60 feet across, so that would be 60, 0. The other point we can find is the vertex. So we are assuming that the highest part of the kick occurred halfway between. Now, there's obviously some fault there, but that's what we assume when we are doing these work problems. So halfway would be 30 feet, 10. So that's how I got the distance, so or the vertex. So from there, we're going to write out what we have. So we have y equals a, and then I have my vertex already. So I'm almost done. The only problem is I do not know what a is. So in order to solve for a, you can plug in a point. So you have two different options. You want to plug in a point that's not the vertex. So we can plug in the point 0, 0, or we can plug in the point 60, 0. Personally, if you can plug in 0, 0, that's going to be a lot easier. So we're going to plug in 0 for y and then 0 for x. And then we will solve for a. So then we get 0 equals, this will be -30 squared plus 10. So then you can square negative 30, which will be negative 30 times negative 30, which is 900. So we get 0 equals 900a plus 10. You can subtract 10. So we get negative 10 equals 900a. Divide by 900. So a equals negative 10 over 900. So we could turn that into a decimal, or we could also simplify it more. So both are divisible by 10. So we can change this to negative 1 over 90. So then our final equation will be y equals negative 1 over 90, and then x minus 30 squared plus 10. Okay, so our last problem here, we have a jackrabbit jumps over a 3-foot high fence. To just clear the fence, the rabbit must start its jump at a point 4 feet from the fence. Okay, so 3 feet high, and then we know that it has to start 4 feet from the fence. So let's go ahead and draw this again. The fence should probably be our starting point. It's a little bit too tall, but again, this is not to scale. Okay, so this is our fence. And we know that it's 3 feet high. Okay, so that's one piece of information we know. We know that the rabbit is obviously going to jump over the fence like that. And then we know that the rabbit, I can't draw it, but is going to start from here. So 4 feet from, which means that this also has to be 4 feet. Because again, we're assuming that the highest part, which in this case is the fence, he will reach the highest part of his jump halfway between. So then now I'm going to go ahead and draw in like this we're on a graph. Okay. So this point would be 0, 0. This point would be 4 plus 4, which is 8, 0. And then our vertex would be 4, because that's halfway across, 3. Okay, so we write out what we have, which would be y equals a, then x minus 4 squared plus 3. So then from there, you pick a point, 0, 0 or 8, 0 to plug in. I'm going to choose 0, 0. So we would have 0 equals a times 0 minus 4 squared plus 3. And then we get 0 equals a negative 4 squared plus 3. 0 equals, so negative 4 squared is 16. So we get 16a plus 3. So negative 3 equals 16a. Divide by 16. So a equals negative 3 over 16. The other thing I wanted to point out is why does this kind of a value make sense? Well, it should be negative. That should be a giveaway because the parabola is upside down, because we don't jump underground. We jump up and over, which makes an upside down parabola. The other thing is that number, the absolute value of it, should be between 0 and 1 because it's compressed. That's why it's so wide. Okay, so that is modeling with parabolas, which is just creating equations from situations.